Hi everybody, and today we're gonna do a merge sort algorithm. I'll explain how exactly it works, and this probably would be helpful especially for beginners and for people who have a slight understanding but not sure how it executes in code. I'll try to make it very detailed. So merge sort is a sorting algorithm that takes usually n log n time complexity, and you'll see why. And I'd probably start, in my opinion, this was the way I learned. So like we would start just like with quick visualization. So let's say we have an array of different numbers and we have to sort it. So the way the merge sort works is we split in every time our array into halves until we get the length of our array, which is 1. Why we do that? Well, simply because when the length of the array is 1, that means that this array is sorted. And you'll see what I mean if you're still confused. So here it splits into two arrays. I'll quickly just do it in this way. Okay, and it doesn't really matter, like, see here, our array has length of 7, and it doesn't really matter, like, which side you want to be the bigger. So, like, we'll just keep 4 elements in the left side and 3 elements on the right side. So here, as you can see, the length is still not 1, the length is still, here's 4, here's 3, so we gotta split it further. So we do the split further, same thing here, if I could draw normally, but that's, well, here the idea of explanation. So again, we're splitting this into halves. This one splits into this. This one splits into this. Same thing here. We'll take the bigger side on the left side and the smaller part on the right side. And we're splitting again. I'll do it like this so we have a little bit more space here. Hopefully, same thing here. And we don't need to split this one. So what we'll do is we'll grab this part, splits into 1, -5, 1 here, and 10 here. Here we split into 3 and 2. So as you can see, why we do this, well, we split till we have only one element. Why we do this is because when you have an array that has only one element, and that means that this array is sorted. So like as you can see here, 6, it's sorted because there is nothing else. Same thing here, sorted, sorted, and so on. So what we do now, so now it's kind of like, if you can see, it kind of sort of looks like a tree if you're familiar with this data structure. And here, what we do is we just simply compare the elements, which one's smaller, and we build up in the way where the smaller element goes first, and then uh, bigger elements goes next. So here we do the comparison. Since we came from this step, we do the comparison. What's smaller, -1 or -5? -5 is smaller, so let's delete this part here. And now we put -5, we put here, and then since there is nothing else to compare with, we just kind of merge this -1 into this array. So this part is done. And now this array is actually sorted. Now let's move further. 1 and 10, which one's smaller? 1 is smaller than 10, so technically here it's already sorted, so we don't need to do anything. Now let's check here. So here again we see 3 and 2, which is smaller, 2 is smaller, so we'll do it like this. We put 2 here, get rid of this 2, and since we don't have any elements to compare against, and you'll see what I mean if it's still confusing to you, but we put 3 here. And now what we have is this array sorted, this array sorted, this array sorted, and this part is also sorted. So now let's build up again. So now what we do is we compare these two arrays together. So let's get rid of this elements. Let's get rid of this, get rid of this, and get rid of this. So now we check. what is the lowest, -5 or 1? So we do the check because we know this is part is sorted, this is part is sorted, so we know the first element would be the lowest. So we check first elements at first. So -5 and 1, which is lower, -5 was lower, so we move it here and we get rid of it technically. Now we do next, we compare -1 and 1, -1 is less, so we build up it over here. And we can get rid of it since we don't have anything to compare with and we know this is sorted. So now this actually part can, so this can actually go into here, and same with 10, 10 can go here, and we sorted this array. So now let's do this part in the same way. We have 2, 3, and 6. Actually, they do fall in a way that it kind of looks like it's already sorted, but let's do for better understanding. Compare 2 and 6, 2 is smaller, so we insert 2 first, get rid of this, compare 3 and 6, 3 is smaller, so we do 3 over here, get rid of this. Since there's nothing to compare with, we only have one element, we just add our 6 here, we sort it. So now these two arrays are finally sorted. So let's build up our final array. So here I'll just get rid of this elements. Sorry, it might take some time here, but bear with me and you hopefully would understand how finally merge sort works. So now again, we compare -5 and 2. What we know is like this array is sorted, so therefore the first element would be the lowest element we found so far. Same thing for this array. So here we compare -5 and 2. -5 is less, so we insert -5 first. Get rid of this. -1 and 2. -1 is less, so we insert -1 here. Get rid of this. 1 and 2. 1 is less, so we actually add in our 1 here. Getting rid of it. 10 and 2. 2 is less, so therefore we insert our 2. Get rid of this. 10 and 3. 3 is less. We insert our 3, get rid of this. 10 and 6, 6 is less. We insert 6, get rid of this. Nothing to compare with, so we're just inserting our 10. And here you can see our array is sorted. And this is quick visualization how merge sort works. And now let's get to the one part. So this is the part especially helpful for beginners. It's sort of like understanding of some little step that you need to understand. So this is kind of like a process of how we do the comparisons and how do we bubble back to the up. So here imagine we have two sorted arrays and we need to create another array out of these two sorted arrays. So here you can see the quick code. I have left pointer, right pointer. I have a left array called L, right array called R. So in here we do our while loop. So here you see our first initial while loop. While left pointer is less than the length of the left array and right pointer is less than the length of the right array, and we have here condition AND simply because you'll see it once we do the comparison. Sometimes one pointer might be out of bounds, but we still have remaining portions in another array and we have to add them, and this is what these two bottom while loops do. So let's do this execution. So for the simplicity also, let me draw kind of like an error here that I'll be moving. Oh, that looks terrible. Yeah, good enough. So here we do the comparisons. Again, our pointers start initially at index is 0. It's sort of like a two-pointer technique. I'm not sure if you're familiar with it, but I'm pretty sure you'll definitely cover it later on. So here we have our left is actually at 0. So our left is actually at index 0. Same with the right pointer at 0. So both of them are actually less than the length of the array left and the array right. So we do the comparisons. -1 and 1. So -1 is less. Therefore, here we insert in our sorted array, we insert this one, -1. So we insert it, and here's we can see, oh my gosh, if I could insert it. Sorry guys, but yeah, so you got the idea. -1, so this was this line, and now we go here. So now our left pointer moves up, and we enter our while loop again. So now we do the check here. Uh, what is less? If it's less, no, it's actually not. Therefore, we go into our else statement, and now we're storing this into our array, and now we have to increase our right pointer, and as well as once we break out of this while loop, sort of, sorry, I should have actually mentioned it earlier, we increase in our I. I is just simply responsible for play as a placeholder like of the index where we insert an element. So like it would increase regardless just because we can't like reinsert the element if already something in there. So we enter in our while loop again, we do the check, 2 and 3, so actually left is less than our right, so now we're placing our 2 over here. We need to increase our left pointer, which we're successfully able to do. And again, we're increasing our I now, so now we can insert at this location. And now we're starting again, and eventually we'll insert 3. We would move, I'll just do it for quicker, like for just to be quicker, because I'm pretty sure that kind of like makes sense to you already. So we insert 4 then we insert 5. Uh, let's do it in a better way. Insert 5, good enough. Uh, we increase our pointer when we insert in 5, then we increase more. So now this is the case we hit. So our actual left is out of bounds, so therefore we would never go to this loop. So now that's why we have these two loops. So now we check if our left pointer is less than the length of our array L, which is actually it's already greater, so we don't even like we skip this while loop and we go to our right, and see here that's how we add remaining elements. There's another ways, but this one I would assume makes more sense and easier to understand. So this was this line, now we move to this line, we increase our right pointer and we increase our I so we can insert something here. So same thing again, we coming back here to this, we need to insert our 7, good enough, and then we increase our pointer R and we increase our I, but then we actually out of bounds, so that means that we finished it, and now we can simply just return our sorted array, and this is how it works. So now let's do the more complicated part. So here you can see I did the code for the actual merge sort, how it works. So like here we have our function merge sort n, which would be equal to the length of the array. If n is equal to 1, then we return this array. If it's not, then we split it and we do left side of it equals to array to the mid and right side of it array from the mid. So here again we do our merge, so we call this again so you can see it actually does it recursively. We have our pointers left and right. We have our length that we're initially getting to. We've created our sorted array which is equals to 0 times n, where n is the length of our array, and you'll see why we do this, and we set our I to be 0, and then we do our while loops, the ones that I showed to you. So how does it work? So let's say we are passing in this function our array R, which is this array. So we do the check. We set it length, which is actually the length of 7. Then we check if n is equals to 1. No, it's not. So let's get the middle. So in this sense, middle divided by 2 would be actually 3. So now we would split this into actually this part. So it would split, we need to split array into this part like this. My bad. So it would actually split array into this part, and let me draw this error a little bit smaller so we can still have some space, and it'll split into array like this. So this is what, let me draw an error here. So this is technically, no, this one does not look good. Let's make it a little bit better. Yeah, I guess good enough. So here, so this condition actually failed. So we go in here and we get in the middle. We got the middle and we created our two arrays. And now we're calling function, and this is where it happens recursively. So once we call this function, now we enter in function again, but we're passing our left, which is actually this part. So now we're actually calling this function again, but with this array now, not with this one, but with this one. So now again, we're getting length of it, which is 3. We check if it's 1. It's not 1, so we go here. Again, we grab our middle, which is going to be this one. So now we actually need to split our array further. So we split in our array further, and it would split into elements like this. And if I could select it, good enough, like this. So this was the split for the left, split for the right. So now we call merge sort on our left. So now again, we're entering function again, but we calling this array. So we do check, we do get the length is 1. We check if that's equals to 1. It is. So now we can return. So we sort of like going back and telling our function L, hey, L, we called merge sort on you, and you actually hit our base case, and we return -5. Okay, so now once we did this, we can go further and see what's going on our right side. And we're going further, we call in this function again, but on this part. So we get in the length of it as 2. If it's equal 1, no, it's not. It's not equal to 1. So again, we do our split again, and it sort of like keeps the track of these functions in which is called recursive call stack. And you can find some videos on the YouTube on recursive call stack, and I think this is the most important part you have to understand about it. And if you wouldn't be able to understand, let me know, and I can try to draw even recursive call stack, how it works within the merge sort and different other recursive algorithms. So again, we did the split. Now we're calling our function L, but we're calling on this merge sort of L on this part. So we enter in this part again. The length is 1 actually. It equals to 1. So now we sort of like going back and returning this part because it actually hit our base case. And then we go, okay, let's check what's going on our right side. And we enter in the function again. We are working with this right side now. So what we do is, what happened here? My bad. So now the length is actually 1. So it's equals to 1. So we kind of going back, we return to our R over here that it's actually 1. And if it is, then we can go further. And this is what happens. This is now 2 sorted arrays that I initially remember showed you. Where was it? Over here. So this is the process how it actually works. Now we're setting our pointers, getting the length of the array, which is in this case it would be 1. Then we create our sorted array of the length times n, and keep in mind that the length times n it actually would be 2, just because we're building up over here, and you'll see what I mean. Like if you want to be even more detailed, let me know in the comments, and I would love to do that as well. But here we set our I 0, and this is when we do our while loops. We do all these checks, and again we compare them. We pick the smallest first, so in this case it would be 2. 2 goes here, 3 goes here, done. So now once it's done, we can actually return it, and we return it to our initially function that we remember when we hit base case on here, and we called the function on the right when it was not length of 1. Now it's fine that it's not length of 1 just because we sorted it and we did all the necessary parts. So now we can actually go further, and now we know that this part is sorted, this part is sorted just because here's length of 1. So let's sort this part. And here again, the same process, same while loop. Again, we pick in our minimum first. So it's actually going to be -5. And now our pointer for this part becomes out of bounds. So once out of bounds, we can just simply, once the left you can see out of bounds, so we can just simply go to this while loop and we go bubble them back up here. So now this part is sorted. So now we can come back and we have an answer for our initial left that we called. We can go into right and then do same process here, exact the same process here. And actually, like, for this sake of time, I'll just do it like this. So eventually it would actually sort up in this way. It would be like this. 7, let's put 2 here and 7 here, and initially we would get the answer for our left and right, and then we can actually build our final array, which is going to be, okay, give me 1 second, have to delete all these parts, which is, again, it's the same process as we did over here. We have 2 sorted arrays and we can build now another sorted array based on 2 sorted arrays. So -5 obviously goes first, then -3, then we have 1 goes here, then we have 2 goes here, then we actually have another 2 goes here, then we have 3 goes here, then we have 7 goes here, and now array is sorted. Well, thank you so much for watching this video. This is the first time ever I'm recording this video, so please, if you have any feedback, even if it's a bad feedback, it's good for me. It lets me to kind of work on my skills so I can help you guys even more. But hopefully you enjoyed this video. Please subscribe since it helps, like this video, and comment. Thank you so much for watching, and good luck with your LeetCode grind.